Okay, guys. Now let's piggyback on, um, the euphoria of CPP.sh coming back by introducing and getting our first real foray here into modular program design. So, in the process of development so far, we have been just kind of vomiting everything up into int main, right? So, the more statements, the more functionality it is that we are introducing into main. Essentially, the longer and longer and longer the uh, the, the scope of main becomes. Um, on a relatively small development, it's not okay, but it's not a huge problem. But the larger and larger your developments become, the bigger an issue this really poses for you and all other future developers along the way. Let's just suppose we have, let's follow one of the examples that we've been doing so far, like the ATM machine. So essentially a bank. Um, if everything was simply, to use a bank term, depositive, just thrown there into main, what happens if I make one small change to, let's say, an output, for example? We have determined that our bank has grown sufficiently large enough that we will no longer call, our clients our friends. We are going to call them customers instead. So as opposed to hello friend on all of our outputs, it's going to say, welcome customer number something. So we're going to refer to people by numbers like this was Prism. The problem with kind of the development that we've been doing to date is that this poses a really serious challenge for a developer. This suggests that I have to, as a developer, know every place it is that I have referred to a customer as a friend instead of by their client number. This on a very large scale application really represents a colossal time expenditure, and really it's error prone. I'm bound to miss something later on down the line. The larger this program grows and develops, the harder it's going to be for any one developer to really have a mental handle on everything that this program is doing. So what we have in not just C++, but in all of the high level languages that you're going to use, we have this idea of functions. A function we can kind of see just skeletally if we flip over to page 300, it's figure 6-1. Essentially, the only change we would really be making to the developing that we're doing so far is rather than kind of the figure on the left being what we've done now, we have just a collection of statements, statement 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down through line 25 there. And it's really hard to say if you haven't seen, if you haven't been involved in the development to date, it's hard to see what exactly that's doing. What we'll be doing is shifting over to what we can kind of see on the right-hand column there. First, we'll have our int main, and main is like the driver for everything. Main is going to, and we'll see this here shortly, it's going to, instantiate any of the variables that we have, and it's going to make calls to the other methods here inside of the body of our program. For each one of those subsequent functions, function 1, 2, 3, 4, or in this case 2, 3, and 4, those are the modular functions that we're going to have. Now, it's important that a function does one thing and one thing only. Now, just words on functions doing one thing and one thing only. First and foremost, we'll start with its name. A function name, very much like we see on page 301, kind of towards the bottom. The name should be very specific. So the function there says display message, and that's actually a bad function name. It's not particularly clear what the message is being displayed to do. Display greeting message, on the other hand, is much better. This, I know, just by reading the name of the function, is going to display a greeting message. It's not that much imagination that has to be invested there. You'll notice that that particular function does literally only one thing. It displays a welcome message. This is It seems like it would be simple, but really this is a challenge in program and process development, is each one of these functions should have only one hyper-specific reason for existing. One of the things I keep leaving comments on, not just here with you guys, but in every programming class I teach, and really in every development I've ever been associated with, is you don't want and. You shouldn't look at a function and say, this needs to do this and this. This should not, display greeting message, should not get a name from the user and display a welcome to them. Is it true that you're kind of, making more lines of code? Yeah, potentially. But later on down the line, as your development grows ever larger, what you are going to be certain of is that if I have to make a small change somewhere, so right here in the greeting message, I want to say hello from the function display message. Well, I have to change that because it's no longer correct. So I know the one place I have a change to make is in the display greeting message function. This keeps me from having to track things down later on. This gives me a higher degree of assurance that when I make a change to one place, that change is going to be propagated across the entire development. And it's not something I'm going to have to find these artifacts of use here and there and everywhere throughout my main, main function. And it's going to really reduce the amount of time it takes me to support and develop any particular function, especially as they grow larger and larger and larger. So functions are really, a fantastic way to make modular program design. It means you can take these little modules of function and plug them in here and there and everywhere, and they have these hyper specific functions that you can use again and again and again without having to essentially repeat again and again and again all of that code, spattered here and there and everywhere throughout your main program. It's a huge benefit to you as a developer. So now that we've talked a little bit about getting good specific function names, let's flip over to kind of a more robust example here from the text. It's program 6.3 on 304 and 305. Here we have just a simple, small program. It has, aside from main, it has two functions. Now, here's a couple of important things to note. During compilation, so before you even get to run the program, C++ needs to have either the full description of a function, or what we'll talk about in the next podcast here is a function stub to actually be able to compile itself. What essentially this means is C++ has zero imagination. Actually, what you'll find is, for the most part, all of your programming languages have zero imagination. If the compiler sees a call to a function that it has not yet gotten a definition to, it will break itself. So these first few small programs, as you're reading through the text, what you'll notice is we actually have all the list of the functions before we actually have main listed out. So on page 305, you can see we have void first. That's the name of our first function on line number 10. And then we have a short, just one line essentially description of what that is. It outputs a message. On line number 20, we have our second function, and it just outputs another line. And then finally on line 29, we have main, and that's finally where we would have historically kept all of our stuff, is here inside of main. Now that we have where is it that I list functions, how is it that I actually make a call out to them? If you'll notice in main, it's actually on line number 32 and 33. Those are my calls to a function. And that's actually how you would verbally refer to that. So that's a function call. I can tell it's a function call because it's got first, which is, it just so happens to be the name of my function, and then the parentheses after that. Anytime you see a name followed by parentheses, you can pretty much be assured that that is going to be a function call. So my first function call is line 32. My second function call is line 33. And there in the program output, you can see, the second and the third lines there inside of the program output are actually the executions inside the function void first and the function void second. Now, we're going to get to, in the next podcast here, why is it called void? And how do we get returns? So how do we get values out of that? We're going to see that next. But a first step here is how do we name a function? How do we display a function? And how do we call a function? And you can see really all three of those things on program 3.6 between 304 and 305.